This lecture is part of an online course of multivariable calculus, and I'm gonna find area of an ellipse using double integral and change of variables. So let me start. First, I would like to graph the ellipse. This is x-axis, this is y-axis. So you see, equation of the ellipse is this. If x is equal to 0, then this part would be 0, so I get y squared equals to b squared, so y would be plus minus b. So I get minus b and then plus b on the y-axis, and then when y is equal to 0, this part would be 0, x squared would be a squared, so x would be plus minus a, so minus a plus a, and I get an ellipse like this. Let me make it a little bigger. Okay, so area would be equal to the double integral of 1 dA over the region R, which would be the ellipse. Okay. One of the applications of the double integral is to calculate the area. How? It's just because double integral of a function f gives me the volume of the solid that is bounded by f over the region R, the region of integration. So when the function is 1, so the solid that I have has the height 1. So the area of this, the volume of the solid would be the height, which is 1 times the area of the base. That's why we get the area in here. I explained the whole thing on the applications of the double integrals. Now to solve this, it's just because I have equation of an ellipse here, I'm gonna use substitution, and I'm gonna let u to be x over a, and then v to be y over b, okay? And in that case, x is equal to ua, so dx would be a du, and y is vb, so dy would be b dv, okay? So instead of dA, I have dx dy, and now I get 1, so dx would be a du, and then dy would be b dv, and then the integral would be on, I need to basically replace u and v for equation of the ellipse, so I get u squared plus v squared less than 1 squared, okay? So as you see, this is a disk, so a and b would be a number, so I will bring them out. So I have the double integral of 1 du dv over the disk, so it would be the area of the circle of radius 1, so it would be a b pi r square, r is 1, so that is the area of the ellipse. Okay, so I would like to give you a note, and the note is that here the substitution works as in one variable calculus, but in general we need to find the ratio, but in general we need to find the ratio between dx dy and the change of variables du dv. Okay, so on the next video we're gonna see how to find this ratio. And here the ratio was just A and B using exactly the method that we used for single variable calculus, but later we need to find something else, that which we call it Jacobian. In the next video we're going to cover that.